All right. Now, I think at the end of class last time, we were doing procedure factories. Do you remember that? And what we had done was we had defined, we wrote this make multiplier factory. It's called define make multiplier. And we had this curious little pattern. It was lambda scaling factor, but then lambda. So it was lambda lambda. So what make multiplier does is it's a function that returns a function. That's what a factory is. And we used it to define double by calling make multiplier with a parameter of 2. And then we used it to define triple by calling make multiplier with a parameter of 3. All right? Is everybody good with this so far? Remember how that worked? And that's why, because make multiplier returns a function, it's after its own lambda, then it's the lambda of the function that it returns. Yeah? Now this was a fairly straightforward example because the function that it returned was not a recursive function. But now here is the pattern, you guys, that a factory has when it returns a function that is recursive. Because look, if a function is recursive, what does it do? If a function is recursive, what does it do? It calls itself. So in order to have a statement in a function that calls itself, that function has to have a name. Do you see what I mean? That function would have to have a name. And so that means that we can't see on this slide right here, this lambda for the make multiplier giving a scaling factor returns a function, and therefore it has lambda. But the function that it's returned doesn't have a name. Where does this function get its name? You know, who gives the function the name? It's up here in the what? Define double. See? Does everybody see what this does? Define double gives the function the name double, and then it calls make multiplier with 2. Yeah? But the problem is, in general, if the function that gets returned calls itself, how are we going to call it? How are we going to have it call itself if it doesn't have a name? So look, what I have here, and by the way, this code is not in the book, but this is the general. This is the slides are available, of course. But here is the general form of the function. So look at it here. It's define function factory. Are you with me? So in the previous case, function factory was make multiplier. So everybody understand that function factory corresponds to like a make multiplier, right? Okay. So define function factory, and then here we have lambda, and then we have the parameter for the factory. Are you with me? Okay. And now instead of having a lambda, what we do is we have a define. So we say define function returned. And then the lambda, and then parentheses, and then the parameter for the function returned. Yeah? And then we're going to have some more code here, ... And somewhere down in this code, we're going to have a recursive call to what? To function returned. See? So there's going to be the recursive call to function returned. And then after the end of this, and we close out the parentheses, then, now does everybody see that this last parenthesis right here is going to correspond to what? To the define, to this define, yeah? Is everybody with me? This is going to correspond to this define. And then what gets returned by this lambda parameter for factory? What's going to be the last thing that gets returned? Function returned, which is this. So there's going to be one step at the bottom that actually returns that function.
But isn't that function also recursive?
Function factory is not recursive. Are you with me?
Yeah.
But does everybody understand the structure here of how this has to work in general? Are we good? Okay, so before we had lambda, but now instead of having lambda, we have lambda define function returned lambda. And then here, this is the code that defines the function. And then after we close out the definition of the function, then we just say function returned, and that's what gets returned by the factory. And then it's returning a recursive function. Are you with me? Okay? So let's do it with a specific example. Now, this gets a little, you got to kind of like wrap your head around this a little bit. It takes a little thinking, but here's an example where we're going to use a factory that returns a function that is recursive. So do you remember repeatedly square? I think we use that for, what do we use that for? To calculate the what? The Fermat numbers, yeah. Okay? So here is, and remember, so what we want is we want to define a function. We're going to redefine repeatedly square. We're going to use a factory to define repeatedly square. So here's how it's going to work. So of course, what our function repeatedly squared is supposed to do, if you will recall, if we say repeatedly square 2, 0, that should give us 2. If we say repeatedly square 2, 1, that should square 2 one time, which is 4. And if we repeatedly square 2, 2, that should repeatedly square 2 times. So it will repeatedly square 4 one time, which is 16, and then repeatedly square 2, 3 should square 16, which is 256. You remember that's what repeatedly squared does. And we had our own way of defining that before, right? But we're going to use a factory this time, just to illustrate how the factory works. So now, what's really crucial to keep everything in mind is there's a difference between the parameter list of the factory and the parameter list of the what? There's two parameter lists. There's the parameter list of the factory and the what? Parameter list of the what? The function that it manufactures. Yes, those are two different parameter lists. Are you with me? Okay? So there's the parameter list of the factory and the parameter list of the function that gets returned. And now here, what is this repeatedly square? Is repeatedly square the factory, or is it the function that gets manufactured? Well, no, wait. Repeatedly square? Yeah. Repeatedly square is the function returned by the factory. Are you with me? That's the function returned by the factory. So look, if we go back to this previous slide, look, do you see then that function returned is going to be what in this example? That's going to be repeatedly square. Are you with me? And then the parameter for the function returned, how many parameters? 2. Is everybody clear on that? Okay, so here, the function returned by the factory is repeatedly square, and it's going to have two parameters. For example, when we call repeatedly square 2, 3, we want it to give us 256. Okay, so check this out. Two parameters in the function returned by the factory. Are we good? And furthermore, what are they? What are those two parameters? The first one represents what? What is the 2? Yes. Well, yes. But we're going to be a little bit more, that is correct in this example. We're going to be a little bit more general though. The 2 is the thing on which to operate, which in this case is the base, so you were right. And what's the 3?
Number of times you operate.
Yes, that's how many times. How many times to operate? Are we good? So this is thing on which to operate, and this is how many times to operate. Right? Okay? And that's the function returned by the factory. But now, so we'll summarize it up here. Here's our example. Repeatedly square 2, 3, and it's got to give us 256. The function returned by the factory is repeatedly square 2, 3. But now, what about calling the factory to make the function? How will we do that? In other words, what parameter, before we actually look at the code, let's try to understand what is the parameter to the factory. So what do you suppose the parameter to the factory should be? How many parameters will there be? Well, here is how we are going to define repeatedly square with our factory. Now, can you tell from this what is the name of the factory?
Make repeated version of.
Correct. Make repeated version of, yeah. And how many parameters does it have? 1. Okay, so you see the difference between how many parameters in the factory and how many parameters in the function that returns. And furthermore, what is the parameter that is this SQR? Is that the actual parameter or the formal parameter?
Actual.
That's the actual. And everybody knows what square does, right? I don't think I'll take the time to demo it. We'll demo it on the board here. Okay, so if you do, parentheses, SQR 5, this is a built-in, right? What will it give you? 25, right? So what is SQR? It is a what? If we did this, if we did SQR, what would come out here?
Procedure.
Yeah, it would come out procedure, I forget exactly, something like colon, some name or something like that, right? Some information about, but it would identify it as a procedure, as a built-in procedure, right? Okay, so not only, check this out, not only is this factory returning a function, it also even takes as one of its parameters a function. So we got really high order procedures here, yeah? So this is how we're going to call the factory to make the function. So here, now, what does make repeated version of do? It returns a function, but the function that return has what? 2 parameters. Are you with me? And then what about this? It has only 1 parameter itself, which is the operation. Now, does everybody see what happens? I mean, how everything is related. It's the function returned has 2 parameters. It does something, but then make repeated version of it's going to make repeated versions of it. How many times? Well, based on what SQR is. So now, can you tell me? Can we anticipate what make repeated version of is going to do? It's going to what kind? How do you do this many? This many times. How are we going to do that? How's it going to do it? If it does it this many times, the function that gets returned, what will the function that get returned do? It'll have a what? It's going to be recursive, so it'll have a what case and a what case? It'll have a base case and an inductive case, and each time it goes through the inductive, well, and what will it check? It'll check if what? If the second parameter is what? The one that gets returned, the function that gets returned, it'll check what? If the second parameter is what? What will the base case be? Yeah, I think it might be 1, because if oh, you're right. Maybe if it's 0, it will return. Yeah. If it's 0, it will return the first parameter. Otherwise, what will it do? It will recursively do this operation on it 1 less time. It will do this one on the thing 1 less time. Okay, so are you ready to see? Can you see without cheating by looking at the book? How can you write this code? Can we write this code? Let's see if we can. So here is the function that we want to this is an example of calling the function that is going to get returned repeatedly square 2, 3. And what it's going to do, and the way we're going to define this is define repeatedly square, make repeated version of SQR. So now look, let's define the factory. So here we go. Now, do you remember what the format's going to be? What's what's going to, how, can somebody tell me what's the first line? Anybody out there? Yes, define, make repeated version of. All right. And then what always comes next? Lambda. But now, how many parameters for this lambda? 1 or 2? 1 is correct. Good. Okay. So it's lambda f. We're going to call it f. Okay. And this f is going to correspond to what when we call it SQR, right? The square function. So lambda f, make a repeated version of f. And now, do we do lambda? We have another define to actually define the thing that we are returning, right? Okay, so it will be define the repeated version. Okay, so that's the name that we're giving it, the repeated version. And now what? Lambda, but now how many parameters?
2.
Why 2? You're correct. 2. Why 2? Because the function that's getting returned has the 2 parameters, yeah? Okay, so we'll call them lambda bn. And here's a little comment. Which does what? Which does f, this function, n times to b. Is everybody clear on this? That's what this repeated version of does. It does f n times to b. Now, tell me, how is this function going to do f? Oh, and by the way, notice that because this is defined inside of this, it has access to f. Remember how we did this once before, didn't we? Didn't we find a function inside of another function that had access to the thing that it was? Okay. So now we should be able to finish this. Can you finish this? How? What's the base case? The function that gets returned, what is the base case? If equals what? If equals, no, I think n0, right? Okay, so if equals n0, what do we return? So if equals n0, what do we return? B. Good. Now, haha, now let's see if we can do this on the board and see if we can predict what's going to come up next. Otherwise, what do we return? Repeated, well, we are going to have to call repeated, no. Yeah, we're going to have to call the repeated version, but, so now what? So, the repeated version, oh, are you peeking? Oh, good. No cheating. Okay, oh, so what is this going to be? The repeated version? So maybe that's what you said in the beginning, huh? You were right, too. The repeated version. And now how many parameters is this? It has 1.
That's 2.
No, sorry. The repeated version has 2, so what do we have? And the first one is going to have to be what? Yeah. F, B, right. Okay, so that's our B, it's FB. And then the second one is how many times? So it's going to do it this, and how many times to that? Minus N1. Minus N1 per n. Yeah, I think that's right. Let's see if we did it right. The repeated version of FB minus N1 per n. Excellent. I think you're with me.
So does this only work for functions that have 1 parameter? Or you have to write a different factory for a different number of parameters?
Yes, what this does is this does only work for functions. Yes, the answer is yes. This only works for returning functions that have 2 parameters.
Is it possible to make a factory that has n number of parameters?
Okay, that's a really good question. Let me just answer that in general. What happens is, scheme is a dialect of what language? Before, let me repeat the question. The question is, what about having a factory that writes, that has more than 1? can have a variable number of parameters. Let me just say generally how that works. Scheme is a dialect of what language? Lisp. And Lisp means what? List processing. And we will see that one of the parameters can be a list. So it's one parameter, but it can be a list with arbitrary number of things. And then it can process that. And we will see exactly how list... You know what's interesting about this whole paradigm is that all this time that we've spent up until now, we have actually not learned how to process lists, even though we've been using them all over the place. And we're going to do that shortly. Anyway, but does everybody see how this works? Oh, I forgot. One last line, because this just defines the repeated version. So what's the very last thing we have to do? So now now that we've defined it, what's the very last thing that the factory has to do? Yeah, it has to return it. So how do we do that? Very last line. How do we do that? What about the... Oh, yes, the repeated version. That's what gets returned. The repeated version. Yeah? Does everybody see how that works? And you know what? I mean, I could demo this, but it'd be boring, I think. I mean, I could, you know, put this into Dr. Scheme and do it, and you would see that repeatedly square 2, 3 is 256, whatever. Okay, but anyway, trust me. Do you trust me?
How does...
Oh, question? That's all right.
I was confused with, like, once it calls the repeated version at the end, how does that...
No. Hold on. Wait. Wait. Yeah. Wait. Let me. Sorry for interrupting. Let me interrupt you right there. When you said when it calls the repeated version right here, let's be clear. It's not calling the repeated version here. It's returning the repeated version here.
Okay.
Do you see what I'm saying? And what happens is up here, when you say define repeatedly square, this is what calls make repeated version of.
Yeah.
And it returns. This is not a call of the repeated version. It's returning the repeated version.
So it's like returning the repeated version of square. Is that like what it's doing?
It's returning. Here, let's take a look. It's returning all of this code right here. It's returning this code only. It's this code, and everywhere there's an F, there's an SQR.
Yeah.
So you can think of it as it's packaging that up, and everywhere there's an F, it's an SQR, and it's returning that, and then that's getting defined to be repeatedly square.
Okay.
See how that works? Now do you see how the functions are really, they're first-class citizens. We can pass them as parameters, we can return them, and we can define. You see how that's really quite amazing. It's quite powerful. And in fact, you know, Scheme, we're going to see this in the next little demo. You know, Lisp, guess what Lisp is written in? How did we start this whole thing that we had two panes, the definition pane and the other, what was the controlling, remember what was the controlling pattern, the controlling execution in that bottom pane? Do you remember what it was?
Interpreter.
Yeah, but remember the three parts to it? It was the read, eval, print loop. Read, eval, print. And so what happens is you are typing a thing and you press return, and what does it do? What does it do? It reads it, then it evaluates it, and then it prints the result. And guess what code behind the scenes is doing that? What kind of code is doing that? Oh, actually, you asked me what is Lisp ever used for? Well, guess what it's used for? Doing read, eval, and print. That's Scheme code that's Lisp code doing it. Reading this and evaluating it and doing lists, because whenever you type everything that we always type is a list, right? What does a list look like? Parentheses, list of things with space between them, close parentheses. All those things are lists. And so it's treating what you do here as a function and evaluating it. Do you see how powerful this is? With just minimum syntax. Look, no, curly braces, types. Oh, another thing, what about the types? Where's int? Where's double? Where's the keyword int? Where's the keyword double? Where's the keyword fraction? What do you notice? What have you noticed this? It's not strongly typed. I mean, is whatever you give it, well, that's whatever type it is, that's what it is. Yeah? So this is dynamic typing too. Yeah? Okay. Now, next chapter is an interesting one, because what we're going to do is we're going to play games. Actually, we're going to play one game, one particular kind of game.
Games are so fun.
Yep. Okay. And the title of this chapter is Compound Data and Data Abstraction. And a very large part of this chapter is the game of NIM. Have you guys ever played NIM? Oh. Frequently I have students who take this class who have actually played. So what happens is here's how NIM works. There are two piles of items. Okay, so you can think of them like matchsticks or coins or whatever, in two piles, right? Players take turns. So first one player, then the next. So you go back and forth, just like in checkers or chess or whatever. Players take turns. And the rule is you take as many as you want from a single pile, but you have to take at least one. Yeah? And then the player who takes the last item wins. Okay, so here we go. Are you ready to play?
Yeah.
All right, so let's go. Okay, so here there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So here's pile 1. And here's pile 2. Okay, we need 2 contestants to play each other. Oh, got a lot of... Okay, how about, Danny, how about you and Shane play?
Okay.
Who wants to go first?
I do.
You want to go first? Okay, so Danny, it's your turn. What do you want to take from which pile? How many do you want to take from which pile?
I'm going to take 4 from pile 1.
4 from pile 1. Wait, does that leave 2?
Yeah.
Okay, 4 from pile 1. Okay, so Shane? Oh, I can see the wheels turning.
Six from pile 2.
1, 2, 3, 4, 5, 6 from pile 2.
Can I take like...
You can. That's the rule. You have to take at least one, but you can take as many as you want from any pile. Is it? Oh, are you saying that she's already lost?
Yeah.
Well, let's go ahead and play it out.
Okay.
Try to make it last as long as possible.
Take 1 from pile 1.
Take 1 from pile 1.
I'll take 1 from pile 2.
You'll take 1 from pile 2.
Take 1 from pile 1.
You have to take 1 from pile 1,
1 from pile 2.
2, and the winner is Shane. Anyone else? 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, you'll take the winner? Oh, we got 2 contestants here. Okay, who wants to go first? Anybody want to go first?
No. I don't want to go.
You don't want to go first? Okay. 4 from pile 1. 1, 2, 3, 4 from pile 1. Yeah, you are going to have to think. I think Shane might know the secret. Well, it's not always true. Well, we'll see. These are good questions. Yeah, we'll see. We'll see. Oh.
I'm gonna take 1 from pile 1.
1 from pile 1. Interesting. Dun dun da 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 dun dun da 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 dun dun da 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 dun da 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 da. Bzz. Time to move.
Take one from pile one.
Oh, you're going to take 1 from pile 1. Now what?
I'm gonna take 4 from pile 2.
Now you're going to take 4 from pile 2. Are you with me? I mean, you see why I did it? Now what? Well, you got to do something. Pile 2, and you won. Have you guys figured out the strategy yet? Do you know this? Shane, do you know the strategy?
I don't know if I know all of the. I don't know if I know a general strategy.
A general strategy. Oh, I see. But you.
Yeah, same.
I can see if I can if one of the piles is at 1 or 2, I can see.
Yeah. Maybe if we do it like this. Now, if there's 2 here and 2 here, I think you guys saw this. Whose ever turn it is to go loses, right? Because the person, he'll either do what?
Pick one from the other pile.
Yeah, because what he'll do is he can only take 1 or 2 from one of the piles. If he takes 1 from this, then you got to take 1. If he takes 2, he'll take the whole pile. So you definitely you never want to be in the position where you take all from one pile, because the other person will just take all from the other pile. So what does it look like? But on the other hand, if you start off like this, what's the first person going? And the first person is going to do what? Take 1. So now do you understand the winning strategy? What do you want to have happen?
Whichever you want to be the one who takes the last one from the bottom pile to make it even.
But what if it's like this? What if you start like this? What should the person who the
person who starts is going to lose if both people play perfectly.
the person who starts first is going to lose if they both, and why is that?
Because if any number he takes, he'll be in the situation
Where the other person can take the same number and then you'll eventually get down to 2-2 or 1-1.
Yeah.
So does everybody see that this loses for the person who goes first? What about this? This loses for the person who goes first. So therefore what? What's the best strategy?
Go second.
Well, but what if it starts off like this? And now the person who goes what? Who goes first can force what?
The other person losing.
Yeah.
Right, and why is that? Yeah, make it so that, yeah?
Oh, so the strategy is to make them even.
The strategy is to make your opponent have the same number, not even odd.
No, I mean an even.
You mean equal numbers?
Yeah, equally weighted.
Yeah. So the strategy, if you can ever get, it's kind of like tic-tac-toe. Once you know the strategy, you can, it's a pretty simple-minded game. Yeah? Is everybody? So the strategy is, if you can have your opponent, when it's your opponent's turn to play, have the same number of items in each pile, you can force a win. And it all depends on if there's the same number of items in the pile to start with, as to whether or not the person who goes first can be a winner or a loser, force the win, or the other, or his opponent can force the loss. Anyway, so are we good? Does everybody see how that works? Okay, so now we're going to have a demo. So guess what? Guess what we're going to do? Guess what we're going to do? Guess what? Yeah. So watch this. Okay, so here's our demo. Now check this out. And I've already clicked run on here, and the code is, we'll do a little code walkthrough here in a minute. But what we'll do, now watch how we start this game up. It's going to be parentheses, and the main function is called oh, rats. I forgot to write down my function call. Oh, here it is. Ah, yes, here it is. I forgot to put it in my notes. Okay, it's going to be, oops, it's in my new notes. It's going to be called play with turns. Play with turns. And play with turns is going to have two parameters. One parameter is going to be a function call called make game state. Make game state. Okay? And now, make game state is a function that takes two parameters, and what do you suppose those parameters are? Yeah, how many in each pile? So I don't remember if I did one with 5 and 8, but let's just do one with 5 and 8. So does everybody understand that conceptually, make game state is going to return the game state? Somehow we're going to have to store the state of the game. And the state of the game is specified by how many items are in each pile, right? So it's going to be make game state. And now, whose turn is it? Now here what we're going to do is we're going to put quote human. And now watch what happens when we press return. No, actually we don't. It seems like we might, but actually we don't. So watch this. Seems he was asking about, do we need another quote? The answer is no. Now look what it did. Pile 1, 5, pile 2, 8. Which pile will you remove from?
Pile 2.
Pile 2. So we'll press enter 2, press return. How many coins do you want to remove? 3. And what does it say? Pile 1, 5, pile 2, 5. I take 1 coin from pile 1. Pile 1, 4, pile 2, 5. Which pile will you remove? Now, let me hasten to add here that this program does not do that strategy, because the purpose here is not to do game theory strategy. The purpose is just to show how this is not that advanced a thing. So what do you suppose his strategy is? Watch this. I'm gonna remove. Which pile will you remove? We're going to do 1, and we're just going to remove 1. It could have won if it had a good strategy, but what did it do? Yeah, it just did the same thing. In fact, what do you suppose it always does? I mean, that's all it always does. Okay, it always picks 1 from pile 1, unless what?
Pile 1
Doesn't have it. So what should we do? Just to illustrate. Let's take 2 from pile 1. So 1, how many coins? Let's remove 2. And see, he just took 1 from pile 2, even though he could have won.
He wants to know what's
Dummy.
Let him win 3 coins from pile 2.
Oh no! Well, why can't we? You don't want to win? We could take 4.
I want to be nice to the computer.
Oh, you want to be? Oh, okay. All right. Then that's a very big heart. Which pile you remove from? 2, and we'll take 3 from 2. Up. I take 1 from pile 2. You lose. Better luck next time. All right. Is everybody?
What's he feeling?
Yeah. How do you feel? Yeah. Actually, we could just. How did you feel beating me? Actually, there's a lot of artificial intelligence. There's a, yeah, you know the Turing test for intelligence. Have you guys ever heard of that?
You talk about it in some class.
I did. Yeah, it's if you can have the definition of artificial intelligence is if you have a conversation with the entity, if you can't tell it's a machine, then it's intelligent. Well, I mean, are you familiar with Siri and the iOS? Where is the nearest pizza place? I located a pizza place near.
I can tell that's not.
You can tell that's not. You can fool that one pretty quickly. Yeah. So you're right. We are a long ways off. Maybe someday machines will get intelligent. But watch this. Before we do the code walkthrough, let me illustrate some features of the code that we're going to be looking at in a minute. Okay, so what happens if I do odd question mark? What's the response? Procedure. It recognizes that as a procedure. Are you with me? So procedure odd, yeah? But watch this. What happens if I do single quote odd question mark? What do you suppose is going to come back? See? It did not. So what did the single quote do? It prevented it from doing what? From evaluating it in this in the read eval print loop.
The same as Excel.
Oh, really?
Yeah, you can do that in Excel.
Oh, wow. Oh, so Excel really is functional. Now, what do you suppose is going to happen if I say human? Like this. Can you predict this?
Undefined.
Yeah, that's getting some error. And notice the little error thing. It comes out in red and has these little icons that says human undefined, cannot reference blah, blah, blah. Okay? But on the other hand, what do you suppose if I do quote human? Yeah, and did you remember that that's how we got the thing started in the first place? Okay, so yeah? Okay. And now how about this? How about if I do plus 2 parentheses plus 2 3? If I do this, what's going to happen? Yeah, but on the other hand, if I do single quote parentheses plus 2 3, can you predict this?
You'll get parentheses, the same.
Yeah. Does everybody see how that works? And furthermore, that's an abbreviation. Suppose we do quote parentheses plus 2 3. What do you suppose is going to happen? Well, just the same thing as a single quote. Does everybody see that a single quote is just an abbreviation for that? And so what would happen if I did quote ABC? ABC. Now, how about this? How about this? How about if I say define me, quote, Warford? What's going to happen? When you do a define, what happens? Nothing. But on the other hand, now if I say me, what? Yeah. Does everybody see how the quote works? Now, check this out. How about printing stuff out? How about if we say display and double quotes, hello world. Hello world, exclamation, double quote. Notice that when I close the double quote, it's nice. And so what do you suppose is going to happen? But on the other hand, how about instead of saying display, suppose I say error, double quote, you goofed. Yeah, in fact, it's going to be that exact same format that gets printed out when errors occur. So inside, remember what we said that scheme is doing the scheme? The scheme is doing the read eval print loop, right? And that's how it makes that come out with the error function. That's how it makes it come out like that. So we have access to the same error function, thing that scheme has. All right. Now, how about this? Let's clean that up a little bit. Start with this clean slate here after all those errors. Now, how about this? New line. What do you suppose is going to happen here? Well, instead of coming right back on the next line, what's it going to do? Come back. Yeah, and if we do new line, parentheses, new line, and then enter this, what's going to happen? Yeah, okay, so new line skips a line. And check this one out. How about if we say read? Because you know we're getting input from the keyboard, right? So how about the read function? What do you suppose happens if I say read? If I say read, watch what happens. That's how that comes out. Are you with me? Okay. EOF stands for end of file. So that's just a little indication that when you press return, that's going to be end of file. And furthermore, if I put something in here like 23 and press return, what do you suppose happens? That goes away and the 23 gets returned. So what does read do? It returns what the user input. Now do you see how we do interactive input? And there's another one called prompt that actually is a little embellishment on read. You can say this. You can say prompt, and then you can put a little prompt string in here, and you can say like, how old are you? How old are you? Question mark. And then when we close this out, and now what's going to happen? It's going to be like read, but first it's going to give the prompt. Yeah, okay. So it'll say, how old are you? And we can say 21. And now what's it going to return? 21. Because whatever the user inputs, that's what gets returned.
What was the difference? Oh, it has the purple, okay.
Yeah, the prompt. Yeah, right before the input thing, right? And if you wanted to, you could do this. Check this out. Here's one way to use prompt. We won't ever kind of like do it like this, but watch this. Plus. Now watch this. Parentheses. Prompt. Double quote. X colon. Double quote. And then what? Because plus takes how many? 2 parameters, right? Prompt, double quote, Y colon, double quote. And so what do you suppose this will do? It'll prompt it for X, we'll enter it. Prompt for Y. Because how does it evaluate a function? First it evaluates the arguments. And so when it evaluates the arguments, it does, are you with me? Okay, so it'll do X, and we'll put like 34. Y, we'll put 11. And now it will return what? 45. Yeah? Okay, so what we're going to do at the beginning, so now these are kind of like the building blocks of the interactive I/O. And what we're going to do tomorrow is we'll see how the game is actually implemented. All right. Okay, so good deal. So we'll start with the code walkthrough on tomorrow. And what did you ask about the homework?
We have homework tonight.
I think, yeah, you do. And one of them is one of those factory things.
Okay.
Yeah. All right, good deal. See you next time.